Today we're going to take a look at applications of exponential functions. Now there are many different applications of exponential functions, but today our focus is going to be on the following three types. We're going to look at regular and compound interest. Think like a savings account at the bank, how much interest you earn over the course of a year and so on. And then also a growth and decay models. These are often population models, maybe talking about bacteria cultures, but they could also be some decay models, which we'll take a look at. But the common example there would be radioactive isotopes from science class. And then we also talk about appreciation and depreciation of assets. That's typically things like the value of a car or a boat, value of property of some kind, or machinery when it comes to things like business. Okay. Now there are four formulas that you are responsible for knowing how to use. What you see here is what will be provided to you on a test. Okay, so the name of the formula and what the formula is. I'll talk you through the formula sheet in a second. The formula sheet that you have has a lot more information on it. But these are the four formulas, so we'll refer to them as formula number 1, formula number 2, formula number 3, and formula number 4. Okay. But let's take a closer look at what these formulas are and kind of talk through them. All right, so give me a second here. Formulas. All right, so the first formula, regular compound interest. So this is the formula that you saw. So A is the future or ending value, so the amount of money in the account after a period of time. P is the initial value or investment or the principal value. How much money did you put in at the start of the period of time? R is the annual interest rate that you're earning, and that percentage needs to be converted to a decimal. N is the number of times interest is compounded in a year. So if it's monthly, N would be 12. If it was daily, N would be 365. If it was quarterly, N would be 4. You kind of get the drift. All right, and then T is always time measured in years. All right. Now this is actually kind of where that number E came from. You're not responsible for knowing this, but when we talked about E, we talked about how it was 1 plus 1 over N to the nth power, and we did the limit as N approached infinity because you can't plug infinity in. And that's basically what we see here if we take the R and the T out of it, all right? And that leads us into what's called the formula for compounding interest continuously. So continuously compounding interest is a similar setup. We still have A, P, R, and T, but now we don't have N because interest is being compounded every moment of every day. It's every second, millisecond, the tiniest amount of time possible. Okay, but because that would be an infinite number of times, we can't plug in N equals infinity. So we get this formula instead. So it's still A is the future or ending value, the ending balance after a period of time. All right, P is still the initial value or investment or the principal value. R is still the annual interest rate. Take the percentage, convert it to a decimal format, and then T is still time in years. Okay, so those are the first two. Anything talking about interest being earned is one of the two. We use this formula here whenever we see compounding continuously. Okay, the third formula is the growth decay model, which looks very similar to compounding continuously. All right, so they changed the variables up a little bit, but it's basically the same thing. Y is now the final or ending amount, but it doesn't have to be limited to a balance in an account anymore. It's not just monetary value. A lot of times these are population values. All right, N is going to be the initial or starting amount or value. K is now going to be a constant specific to the substance or population we're talking about. Sometimes we solve for it, sometimes it's provided. And then T is going to be time. The important thing here is time is not guaranteed to be measured in years, but it would be told to you in the context of the problem. Are we talking about years, days, months, weeks, minutes, seconds, etc.? It'll tell you in the context of the problem. All right, and then the last one is the value of a piece of machinery or a building or something along those lines, like a car, a boat. So this is value over time. Things that can appreciate in value go up in value, depreciate in value, or going down in value. So we use the plus sign when we're going up in value and the subtraction when we're going down in value. So V sub N is the future or ending value of the object you're talking about. P is the initial or starting value, that principal value. R is the fixed rate of appreciation or depreciation, again, percentage converted to a decimal, and N is back to being the number of years. Now, why they use N instead of T, I will never understand, but that's just what the formula is, okay? So again, you're responsible for knowing what all these letters stand for. However, this is what you'll be provided with. And as we go through the different examples, you'll get a sense of where the numbers go, and hopefully these will feel relatively straightforward once you pick out which formula to use. All right. In the next video, we'll talk through the first few examples, and then we'll go from there. See you there.